7 day 3 has us pick up where we left off at in section 7.1.1, and really what it's asking us to do is make a lot of conjectures about kites, and there's a lot of different conjectures that we can make here. So again, I sort of skip this and kind of, I mean, I don't skip it, I just sort of take a part of it and we do that part and I sort of ignore the rest of it. But I did want to start with a proof, so we will go back over to that Ferromax website that I like, and we will do congruent triangles 2. So let's see if we can find that one. You can see this is a level medium, and you can see there's a lot to this one. So again, there's a bunch of different ways that we can go about this. So what I would love is if you would sort of, maybe pause the video and see how far you can get in this, or when you see the first statement. So I'll just start with the given line AC bisects BAD and BCD. So I know that that is true because and now I have a list of all the other reasons, right? So if you kind of put these two together, you should be able to maybe do this one for yourself, or even go to the website and try it for yourself. Now, the way we talk about the way these things go in order, we can sort of AC bisects BAD, AC bisects BAD. So think about what that means. I can either go straight to the next given, or I can try and tell the story in order, and neither one would really be wrong, but I think what I want to do is try and tell the story in order. Why did they tell me the AC bisects BAD? I'll bet you angle DAC and angle BAC is congruent is one of my choices. So DAC and BAC is congruent because that's what it means to bisect, right? You cut in half. So I'm gonna run with that logic for right now. I'm gonna say that's true because that's the definition of an angle bisector. Also, AC cut BCD in half, so I can say DCA and BCA are congruent as well. That would make a lot of sense to say that those angles are congruent. And again, I'm going to say that because that's the definition of an angle bisector. So again, I'm trying to tell the story in order. Now I'm going to go with the next one. DC is perpendicular to AD. And how do I know that DC is perpendicular to AD? Well, that was given. Now, who cares if DC is perpendicular to AD? Well, I think that would mean that angle D is a 90-degree angle, right? So I'm going to say angle D is 90 degrees because that's the definition of perpendicular. And you can see what's happening here. I'm using this plot here, right? I start with the given and end with the proof, but the given's becoming evidence. And here's what I mean by that. It gave me that it was an angle bisector, so I used angle bisector in the definition. It gave me that it was perpendicular, so I used perpendicular as far as a reason, right, in the definition. So you can sort of see how these work together, and now I'm sort of working my way through here. So let's see here. What about if I say AC is AC because reflexive, and then I do triangle congruence? So AC is AC because reflexive. And now I could say these triangles are congruent because of angle side angle, right? So these triangles are congruent because of angle side angle. Now, why would I prove that angles are congruent? Triangle congruence and CPCTC go together. So I'm going to probably use some CPCTC over here, right? So I'll say, hey, look, angle D and angle B are the same, because that's what CPCTC tells me. And now finally, I'm going to end with what I'm trying to prove. And I only have one extra choice, so it's got to be transitive. But transitive is very much like substitution. Like, hey, this equals 90 and this equals this, so they equal each other, right? If A equals B and B equals C, then A equals C. So if A equals C and if A equals B and A equals C, then B equals C. So these must be equal because of transitive. And let's see if that's true, and I got it right. So a lot going on with this proof, but you can see how I was able to use this logic, right? I started with the given and end with the proof. I told a logical story. The given did become evidence later. I didn't need to know anything about shapes in this one. I didn't have any parallel lines in this one, but I did have triangle congruence and CP/CTC going together, right? I proved that the triangles were congruent and then immediately used CP/CTC right after that. So that's just a little bit of an insight into how this stuff goes and works together. Hopefully that makes sense. All right, so now again, I said I was going to do some stuff with kites here. Really, it's really similar to what we did yesterday with kites, except for I'm going to try and push this onto you to see how you do with it. So let me go ahead and pause this and set this thing up. This goes so much better if you try and pause this video and like learn for yourself and use this plan that we have of trying to go through and fill in as much of this as we can from the beginning, and then using these note pages and filling the note pages in as we go along. So I would say just really try and be mindful of that. But long story short, ultimately what I really want to prove is that GE is the bisector of FGH. And if you'll remember, that was really similar to what we did in the last video. So I would tell you, if you could do this yourself, that would be fabulous. You can prove part A in 4 steps, part B is an extra step, and part C is an extra step. So if you can try to make that happen, I think that's the best way to do it. Ultimately, it's like a 6-step proof, but you can definitely do it. I think it's easier to sort of hit these targets. So first, let's prove these triangles are congruent. Once we've proven that, let's prove these angles are congruent. Once we've proven that, let's prove that this is the angle bisector. So first thing I'm going to do is I'm going to start with my given. EFGH is a kite. And I know that because it's given, right? And I know that somewhere down here, and I've already told you it's 4 steps, right? So I guess in step 4, I'm going to say that triangle GHE is congruent to triangle GFE. So how do I get to that point here? Well, first of all, I know that I'm going to say that this is a kite. So again, if we go back through, we need to know, went on the wrong one. We need to know our shape definitions, right? So what does it mean to be a kite? And again, hopefully we already have that down, what the definition of a kite is. So we should know that a kite is like sets of congruent parts. So I'm going to say that GF is congruent to GH, and I'm going to say that FE is congruent to EH. That's what I'm going to say. And by the way, you could break those into 2 different steps and make this 5 steps, but I'm just going to make it 1. So I'm going to say GF is congruent to GH, and I'm going to say FE is congruent. Kind of running out of room here. So let's give myself a little bit of room. It's like a tiny eraser. I'm not used to it being so small like that. Anyway, and I'm going to say that FE is congruent to HE. And both of those is because it's the definition of a kite. And now what I'm going to do on step 3 is I'll say GE is congruent to GE. And hopefully we all know that's the reflexive property. And now what I've done is I proved these triangles are congruent because of side, side, side congruent. So hopefully part A was pretty easy. We've already done this before, so hopefully you kind of see this coming. I'm just trying to reinforce what it is we've already learned. So now we should be able to prove that angle FGE is congruent to HGE in 1 step. So hopefully you can kind of go over here, and I'll tell you it ends up being this one, right? We proved this triangles are congruent, so we should be able to say the corresponding parts are congruent. So I'm going to say angle FGE is congruent to angle HGE. Angle FGE is congruent to angle HGE. And I know that's true because of CP, CTC. So that was part B. By the way, you can't just go straight to part B. You had to do steps 1 through 4 before you could do step 5. But I now know that these are congruent. And then finally, hopefully this is ringing a bell already. If it's not, step 6 is 1 step. So I can just say GE is the angle bisector of angle FGH. And how do I know that? Well, look, these are the 2 halves. So that's the definition of an angle bisector. When you cut an angle in half and you get 2 equal halves, that's the definition of an angle bisector. So there we go. That is it for day 3.